Hello, so in this lesson we're doing lesson 5 of the light booklet, which is looking at how cameras work, as well as projectors and magnifying glasses. Now please make sure your phone is put away so as not to distract you. You've not got the TV on in the background, you're not playing any games, and you've got your notebook, your booklet ready to take notes and then answer the questions at the end. So we're going to have a look at how cameras work. And we know that cameras are used to take pictures, something you all know already. What you might not know is that a camera uses a convex lens to focus an image onto the screen to take that picture. If you're not sure what a convex lens is, do go back and have a look at your previous lessons and videos done by Mr. Rahman to help you out there. We've got here that we've got a convex lens. You'll notice that it is curving outwards. Concave would curve in. A convex lens is wider in the middle than it is at the ends. And we've got our picture or our object we want to take a picture of. And this is our camera here. I'll just draw our camera. This bit can move in or out as we want to focus it. The reason why we might want to focus it is that this object, it must be more than twice the focal length. What do I mean by focal length? I mean the point where the lens will focus light as it's shining through from straight on. So our focal point could be about here. So this is our focal distance. And up here is twice the focal distance. Now you might be thinking, okay, right, how do we now take that picture? We're going to show you. We're going to look at what's going to happen to light. So light's going to come from the sun or any lights we've got around us and reflect off of the object. We've done reflection, we know about the angles of incidence and angles of reflection. We can do that. So the light's going to reflect off. So we're going to draw a beam of light coming from the top of the tree. It's going to come to here. It's going to go into the lens. As it enters the lens, it will refract. So it will change direction. It's going to slow down, so it's going to bend towards the normal. If we draw our normal on there, we're going to get a change in the direction of the light, and as it comes out it's going to bend away from the normal as it speeds up, and the light's going to go down that way. As we can see, it's suddenly gone from being at the top up here to right down at the bottom down here. We'll draw another line, so we'll have one coming from here this time. Our light will refract again and come out this way, and we'll have another one that will come down here, so going at a massive angle because it will be reflected in all directions and again refracted in all directions. As it comes out, we're going to refract again as it comes out, and we see that our image is now inverted. So our image is inverted. What do I mean by inverted? I mean it's been turned upside down, which is something very, very interesting. You might not have known, you might have already known it, but with a camera, it's actually taking the picture and turning it upside down. So when we print it out, we then turn the photos the right way up so that we can see them as we recognize them. Be no point you wouldn't want all of your pictures upside down. And the image is real. Why is it real? Because it can be captured on a screen. So you'd have your screen at the back that you would take your photo onto. But our important things here. We must be more than twice the focal distance away. The light goes in and is refracted. It changes direction, or it bends towards the normal. or moves towards the normal as it slows down going into the lens because it's more optically dense. And the image we get is inverted, and it is a real image. It's turned upside down, but it can be captured on a screen. We're now going to have a look at projectors. So projectors sort of do the opposite to cameras, and they will project an image, so a small image, onto a screen. If you've ever been to the cinemas, I know we can't go at the moment, but if you ever have been previously in the projection booth, they have a very, very small clip of what the film is, and it's made massive onto the screen, and they use a projector to do that. And a projector also uses a convex lens, just like a camera. But this time, it works in reverse. We've got our convex lens, and we've got our object. Again, we are more than twice the focal length. And our image here is upside down. So the image to be projected is inverted, or is upside down. The reason why, and see if you can work it out yourselves, we're going to have that light travelling through the lens. So we're going to have them all coming in at various different angles. Where do we think these are going to end up? That's right, we're going to end up being basically the other way around. And so forth. So the image will be made bigger while we do this. So a projector makes the image bigger. And it's the right way up now. And again, it is a real image. The reason why it's a real image is that we can put it onto a screen and lots of people can see it. So it can be seen on a screen. So we class this as a real image. It works just the opposite way round to a camera. Same principles, they're the same way round though. Finally, we've got a magnifying glass. So magnifying glasses, if you ever use one of their handheld things, they will make objects appear bigger. Use them to look at very small things, a bit like a microscope, but it's handheld and it's just one lens. Again, it uses a convex lens. The object being magnified must be placed before the focal point. The reason we do that is that we don't want the image to be inverted. We want it the same way up. And the image is a virtual image. So only the person holding the magnifying glass can see it. We can't project what we magnify onto a big screen. So we've got here, again, we've got our convex lens. And we've got our distance here is the focal point. This time I've taken a very small tree and we're going to magnify it up. Again, so at this point, because we're now before the focal point, we're not going to get that same changing because the light's not passing through the focal point. So we'll go to here, and down to here. And our image, when it comes up, will appear bigger. So in this case, our image is not inverted. It is a virtual image. Now you might want to work out how much bigger it is. So there's a very simple calculation we can use for this. I'm just going to show you down here. So the magnification is equal to the image size, so how big it has become, divided by the original size. So if this was, we'll say this is 5 millimeters big, and this is 50 millimeters big, we would do 50 divided by 5, and that will equal 10. So it's made it 10 times bigger. Apologies, that's squeezed on in the bottom corner there. Now you have some questions in your booklet to complete. I have put the answers on Show My Homework as well for you to check. Some of the questions are linked to what you've done in previous lessons, so looking at the eye, for example, and how the eye works, whether people are short-sighted or long-sighted. But the eye still has a lens in it. Again, it's a convex lens. Does a similar thing to a camera. It will invert the image onto the back of the screen, and we can focus it in the same way. So slightly differently, in the eye we change the size of the lens. In a camera we move the lens forwards or backwards to focus the image. But do have a go at completing those questions. If you do have any questions or any problems, please do send me an email or contact me on Show My Homework. Thank you very much. Have a good day. Bye bye.